1, 2, 3, buckle my knee. Alright, looks like easy. Back to easies. There's been a fair amount of easies recently. Really surprising. Anyways, sum of root to leaf binary numbers. You're given a root of binary tree where each node has value 0, 1. Each root to leaf path represents a binary number starting with the most significant bit. Sure. For example, if the path is 0, 1, 1, 0, 1, then this could represent 0, 1, 1, 0, 1 in binary, which is 13. For all the leaves in the tree, consider the numbers represented by the path from the root to that leaf. Return the sum of these numbers. Okay. So 1, 0, 0 is 4, 1, 0, 1 is 5, 1, 1, 0 is 6, 1, 1, 1 is 7. So it's the sum of 4, 5, 6, 7, which would be 22. Okay. All right. So here, this 1 represents a 4. It's a binary tree, so every node has 2 leaves. I assume. Or is a binary tree something that every node has at most 2 leaves or 2 children? So if all the paths from root to leaf has the same amount of nodes, same length, then it would make this pretty simple. But I don't think a binary tree. What's the definition of a binary tree? I don't think it guarantees that there's a maximum of 2, but it doesn't necessarily mean there's 2 exactly. Yeah. Okay, so the path could be as long as if I have uneven paths, like 1 goes to 0 goes to 1, and 1 goes to 0. So you have the value up to a node, like 1, 0, and that goes to 1. So the 1, 0 represents 2 at that point. So the value up to a node, the path up to a node is shifted over by the length of the children. So 1, 0, because there's a child of length 1, is shifted over 1 to the right, to the left. If this was another, let's say 0 here, then 1, 0 up to this 0, the path up to here needs to be shifted by the length of the children. It really doesn't work recursively, I don't think. I think maybe if I have a global answer, and I recursively iterate to the leaf nodes, then whenever it hits a leaf node, it adds the value of the path to it. Yeah, okay. So let's say I have a global answer. And let's say I have process a node, which is a tree node. And this will return this doesn't return anything, I don't think. Yeah, it doesn't really return something. Actually, yeah, I think that's the correct syntax. Anyways, if this null is not none, then just return. Because I'm going to recurse to the children. So the value of the path up to now, each node has a value. I think maybe I need to actually pass down the value of the path. As I recurse down. So I think it's something like path value should double because it's shifting over to left by 1, and then it should add on to it whatever the current node's value is. That's not the correct syntax. Path value times 2 plus node value, and then I think it's something like process node.right, node.left, path value, process node.right, path value. Actually, I think it needs to check whether or not it has children. It needs to check whether or not it's a leaf, so this action doesn't apply. If it is a leaf, then it needs to update the answer, increase the answer. So if not node.left and not node.right, and this is leaf, okay, answer. So I guess technically it's always going to do this. Path answer plus equals path value, and then just return. So if it's process the root 0. So it starts with calling the root 0. The root has a path value 0 initially, doubles it, plus 1. So the path value up to the root here is 1. It's not a leaf node, So it's going to go to process left path value. So it passes here 1, goes to this node, passing path value 1, doubles it, becomes 2 plus 0 is 2. It's the same thing as 1, 0. It's not a leaf node. It's not a leaf node. But it could have a null, it could have an empty node on one of the ways. Yeah, so I think this needs to be, I need to check for none here still. I guess I still need to check for none. Just because it could have, like, if this one wasn't there, then at this point it needs to, if it calls node.write, it can't just crash. So I think that's right. Answer is not associated with the value. Is it not? All right, let's see if that fixes it. All right, sweet. All right, so summary here. This also could have been done without recursion. This is probably the same speed roughly. Might be slightly faster without recursion using like a stack. Summary. Code uses recursion to traverse all paths from root to leaf nodes when it reaches on that recursive path. Is this breadth first? It's just depth for search. Passes the path value up to that node. If that node is a leaf node, will increase the answer variable, which is uploadable, by the total path value up to that node. Whenever path goes through a node, the previous path value is doubled and increased by the node's value. For instance, if you have a previous path of, say, 1, 0 into node that's value 1, then this is 101, which is 1, 0 times 2 plus 1 in binary. I guess I can say this is 3. 1, 0, 1 is 5, which is 1, 0 is 2 times 2 is 4 plus 1 is 5. All right, I mean, that's pretty straightforward. Time complexity, this can be O of of n, where n is the number of nodes in the tree, since the recursion will go through each node exactly once. And then space complexity is going to be O1. I guess it's going to be O of k, I think, where k is the maximum maximum length of the tree, since the recursion will have each node on the call stack. In theory, k is less than or equal to n, so it would be O of n. Possible to do the above without recursion using some sort of stack, or maybe a queue. But for simplicity and ease of comprehension, use recursion.